here. Okay. Now in the roadside garage, you have seen the operator, they are welding. Then you can see there is a glowing part. That glowing part is the arc. How arc is made or formed? Here, see, you have a one terminal here, and second terminal is the workpiece itself, the workpiece which you want to weld. So here in this space, so you can manage the electric field by just managing the power source. So in this space, when the electric field exceeds the breakdown voltage of air, then what happens? Here in this space, the air forms into or converted into plasma state, and as it is already under electric field, sorry, then that plasma state set up a current. That current is nothing but that glowing arc, and that glowing arc, you got a concentrated source of heat, and that heat is used for welding. So in the previous type of welding, you got the concentrated heat out of chemical energy. Here you are getting a concentrated source of heat out of electrical energy. So, and one thing, this electrode, if this electrode itself is used as a filler material, then we say this is a consumable electrode. And if you are using a non-consumable electrode, then that is called a non-consumable electrode. And that kind of welding, arc welding, is called gas tungsten arc welding. Here electrode is used or made of tungsten, which is a very high melting point material. So tungsten is used as a non-consumable electrode, and where you are using a consumable electrode, those welding arc welding processes are submerged metal arc welding and MIG, gas metal arc welding. Now,
Sir,
huh,
sir, consumable electrode means it will be used in this
as a
welding
filler, it
as a
itself
filler.
will melt. It itself will melt and fill the gap of joining.
And sir, in diagram there is also use of filler metal sometimes. It is
Huh.
written.
When
So
suppose you are using a non-consumable electrode, tungsten TIG, but you need a filler material because the process requires, then simply you will add extra material, filler material. So this figure is showing that setup, filler
Sir,
sir,
materials from outside.
so what is
sir,
the long form
Hmm.
of the GMAW and SMAW?
Submerged metal arc welding. This GMAW is gas metal arc welding. Here gas tungsten arc welding. Okay.
Okay, sir, got it.
Hmm.
sir, here the workpiece is acting as an electrode,
One of the electrode,
and the second one is the consumable electrode, consumable or
consumable or non-consumable, because you are creating source of heat, the arc itself. Okay, now so you have to make one of the part or terminal is the workpiece and another is the electrode. We have fewer less slides. For before that one, just I want to make you or ask you whether you can understand or not. Say you have to join two slides or slab, sorry, say of dimension of 50 mm, 50 mm and 50 mm, and you are using a source of heat of this diameter and of this diameter. Okay, say this is option 1, this is option 2. Oops. This is option 2. Now, my first question is, after joining or after welding, will you get 100 mm thickness or length, width?
No, sir.
No,
Why?
sir.
Why?
No, sir.
Little less.
A
Because
little less.
Less
Little.
than 100 mm.
because you are a little less or maybe little more. Why? Because you are disturbing the solid portion here and here and let it solidify. But if that expansion, that liquid expansion is such that it is making more than 100 and maybe less than 100, you got the point. But if it is making more than 100, then here the thickness will be lesser because of volume conservation. And if they are making of same thickness, then it will be less than same or more thickness here, the molten metal, then you will get a lesser than 100 mm. You got the point. Now my
Sir, can you
second,
explain again?
I explained, you answered that less than 10, 100 mm.
Yes,
But
sir.
I also told you one case that it could be 100, more than 100 mm, only in case if this liquid metal in this gap forms in such that its thickness is lesser than the thickness of this parent metal. Then it will, by volume conservation, it will take the space in this direction. You got? Then in that
Yes,
case,
sir.
one of the possibility, it would be more than 100 mm.
Sir,
But
we cannot use
Okay,
filler
sir.
material in this, no?
no, you are not using filler material.
Okay.
Now my second question is that this is option 1 is this diameter source of heat, and option second is this diameter source of heat. Okay, and I, in the first question, I told you some possibility of more than 100 degree centigrade. Just forget, simply you are making of same thickness. Welding is of same thickness. Now, will you get, sorry, so same thickness, forget, I'm giving you more conditions. Simply say you are welding with option 1 and option 2. Now, in which option you will get more accurate or more close to 100 mm width,
Second.
more
Second.
close, or say more accurate?
First one.
Sir,
One.
first.
One.
One. First
One.
one, sir.
First one. Last one, sir.
First one.
First one, because you are disturbing very less solid part. Okay,
Yes,
now,
sir.
so am I clear?
Yes.
Now I'm going to further. Now, flux. So flux is used for making protective layers. Flux is what? Flux is a material which combines with the metal oxides and impurities in the molten metal. And when they combine with metal oxide and impurity, they form a substance called sludge, and that is lighter or less denser than the molten metal. So they float over the molten metal and make a protective layer. So for extra that making protective layer, flux has been introduced in arc welding, and this you didn't see in gas welding. So now here what is given, flux is usually formulated to serve several functions. What are the functions? To remove and prevent oxide. How? It combined with the metal oxide and forms sludge, and it simply float over the molten pool. Second, provide a protective atmosphere. How protected atmosphere? Is make a protective coating now. Then further contamination of atmospheric air is abandoned. or restricted. Now third purpose is stabilize the arc. Is it making a protective layer, so no further reaction with the atmosphere, so no disturbance, extra disturbance to the arc, so it's simply stabilizing the arc. Fourth, reduce spattering, as it is making a protective layer, so it's also reducing the spattering of liquid metal. Flux
Sir,
delivery technique. Oh,
so sorry,
sorry.
sir, but I did not got the flux meaning, sir.
Flux. Flux is a
Yes, sir, please.
material. Flux is a material which is used to avoid or make a protective layer over the molten metal. How? These flux combine with metal oxides. So while welding, the molten metal which catch oxygen, atmospheric oxygen, and will form metals now. So what this flux does, this flux combine with the metal oxides and also with other kind of impurities and forms a substance called sludge, and that is lighter or less denser than the molten metal. So they simply float on the surface of the molten metal and make a protective layer. Did you get?
Yes, sir, got it, sir.
Yeah. Now how flux is delivered? So there are three processes of delivery of flux. First one, simply from outside into the arc or welding zone, we put or pour the flux in the form of granular form. And second way of delivery is we simply coat the electrode from outside with the flux. And third,
Excuse me, sir.
uh,
Sir, can you explain fourth point of the flux?
reduce spattering.
Yes, sir. Yes, sir.
Spattering means simply it's reducing the scattering of liquid molten metal. How? Is they are making a protective layer now, covering layer of the liquid molten metal. So further spattering of liquid is reduced. If spattering is there, then the quality of weld will be bad now. Finishing, you will require more finishing after welding. You have to clear those spattered metal. Did you get?
Yes, sir.
Now here third delivery is these flux is introduced in the central part of the core of the electrode, consumable electrode. So there are three kind of delivery. Now here types of, here these are electrode rods, and here is a continuous wire of electrode, so spool of electrode. So in this first kind of electrode, it is smaller in length now. So when you make a larger weld, then when first electrode is finished, then you have to stop and attach the second electrode. So it's a kind of interrupted welding, and if you don't want an interruption, then you can use this continuous electrode. Okay, here some technical characteristics or dimensions are given for welding rods. You can see now here this means these are another categories of arc welding: metal arc welding, gas metal arc welding, and another is tungsten arc welding. So here in gas metal arc welding, we are using consumable electrode. Here this red part, sorry, let me full screen. Here this red part is the electrode wire. This yellow part is for shielding. And one more thing, we are not using flux here. In place of flux, we are using shielding gas for shielding purpose. This shielding gas also prevent the atmospheric pressure to penetrate or infiltrate in this molten zone. So by using shielding gas, you are restricting the further contamination of the liquid or molten zone. So same purpose is served. And for shielding gas, we generally use argon gas. Okay. Now gas metal arc. After completing, I will show the video. Now gas metal arc welding features. It uses consumable wire electrode, and it uses inert gas for shielding purpose. Generally, argon gas is used. No electrode coating, because you are using a shielding gas, so there is no coating of electrode with the flux, no flux. And DC, direct current reverse polarity used. This is reverse polarity when the electrode is attached with the positive terminal, then we called reverse polarity, and when the electrode is connected with the negative terminal, then we called straight polarity. Okay. Now here this is the uh, setup for gas tungsten arc welding. Here tungsten electrode is used as a non-consumable electrode. The difference is only this. So whenever required, you filler material, you have to add external filler material. Here also for shielding purpose, shielding gas is used, not flux. What are the features? Same I explained. Non-consumable tungsten electrode, inert gas for arc shielding, with or without
Sir,
filler.
sir, in previous slide, sir, the
Yeah,
shielding gas argon.
yeah. Hello.
Hello,
Hmm.
so I'm
Uh-huh.
audible. So,
You are audible.
shielding gas, how is coming here, sir?
Through the passes they have done.